On this last page, I'm giving you a few more practice problems just to practice the concepts a little bit more. So in experiment 1, it's an imaginary experiment looking at the effect of classical music on exam scores. In this experiment, 2 people are listening to classical music while taking the exam, and 2 people are listening to silence while taking the same exam, and everyone has an exam score. So type of music is the independent variable, and exam score is the dependent variable. In this experiment, time of day is just an extraneous variable that's not being studied. And it looks like everyone is being tested at 10 a.m. What I want you to do is calculate the mean exam score of the classical group by adding the 2 numbers and dividing by 2. And I want you to calculate the mean of the silence group by adding the 2 numbers and dividing by 2. Once you get the mean of group 1 and the mean of group 2, calculate the difference. To get the difference, just subtract the mean of classical by the mean of silence and get the answer. And that's the difference. It's how far apart the 2 means are. And then once you do that, once you calculate the 2 means and the difference, move over here to question 1. This is multiple choice. And answer the question about this extraneous variable of time of day. And decide if time of day is controlled, if it's balanced, or if it's a confounding variable. If it's the same for everyone in the experiment, and it never changes, it's controlled. If it's half and half for group 1 and half for group 2, it's balanced. And if it's unequal between the groups, it's confounding. And then in question 2, tell me if time of day ended up skewing the difference between the 2 group means. This is just asking, did the variable of time of day cause this difference to be either exaggerated or inflated or reduced and made smaller than it would otherwise be? So basically it's asking, did time of day make this difference inaccurate? So skew means inaccurate. So it's basically asking, did time of day cause this difference to become inaccurate? Yes or no? In experiment 2, it's the same thing, but what I want you to do here is imagine that when a person takes the test at 6 a.m., they're tired and they suffer a performance penalty. And for this activity, let's imagine that penalty is 20. So if it says 90 here, subtract 90 by 20 and put the answer in the box. And the number in the box will be that person's actual score, right? So if 90 minus 20 is 70, then you would put 70 here, and that's their actual score. And this is just the score that they would have had if it had been at 10 a.m. So it's just a baseline or a starting point. This is their actual score. So when you calculate the means and the difference, take the number in the box, or if there is no box, take the number that's there. So it's this, 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 and this. And calculate the mean of classical, the mean of silence, and the difference, and see what happens. And here, look at time of day on the left side and tell me if it's controlled, balanced, or confounding. And once again, tell me if you think that time of day caused the difference to become inaccurate or biased. Yes or no? And for experiment 3, it looks like group 1 is all 10 a.m. and group 2 is all 6 a.m., which means that the 2 scores in group 2 are both penalized. So subtract them both by 20, fill in the boxes, and then calculate the mean of these 2 numbers and the mean of these 2 numbers. Get the mean, and the difference, and answer the 2 questions. And that's it for this activity.